longer starting at the origin. We're going to start someplace else. And that someplace else that we start at is going to be some value of h and k. Now, the value for A, the value for B, the value for C all means the same thing. The only thing that changes is that we're moving our starting point. All right? So let me give you guys what the formula from the generic of the ellipse looks like and go from there. On your, on your ellipse sheet, the one that I gave you yesterday, the only thing that changes here, instead of it just being x squared, it's x minus h quantity squared. That's the only thing that changes. So what's happening here, you have something that looks like this, x squared over a squared, blah, blah, blah.
Yeah, we do.
The only thing that changes is that you're shifting where the x starts. That's it. So you have x minus h quantity squared over the a squared plus y minus k quantity squared over b squared equals 1. That, again, is a shifted left and right because the a squared is underneath the x. And if it's the other way around, x minus h quantity squared over b squared plus y minus k quantity squared over a squared equaling 1, then it's just shifted up and down. Like I said, guys, the only thing that's changing today is our starting point. That's it. All the rules and all the stuff that we've been working on, it's all the same. It's all the same. You're going to be pleasantly surprised at the simplicity of this again. Hopefully. Well, you might be surprised one of these days.
Yesterday was easy.
Good. Well, then today shouldn't be that bad.
When is it, like, is there a reason why you use the a squared under the x or b squared?
The a squared term is always larger than the b squared term, and that tells you what direction things are moving.
But so if it's on the left, then
yeah, just like we said yesterday, if a squared's on whichever one is the larger of the two, that if it's underneath the x term, it's stretched left and right. If it's underneath the y, it's stretched up and down. That's all that was. Okay. So let me show you guys what it's going to look like when we go to graph. We're going to jump right into it. Okay. We're going to jump right into it and walk through it. And like I said, when we graph these, we're going to identify. And yesterday we identified our vertices, our co-vertices, and our foci. Remember that? Well, today we're also going to identify where our center is because we have to know where to start. It's your H and K. Yeah. Okay. So basically what we're doing here today, guys, is just adding one step to what you did yesterday. The only thing that we're adding is where to begin. Instead of starting at 0, 0, in this case we start at 3, negative 6. That's it. That's it.
Let's just get to the
But like, wait, I have a question. So does like the top, so like the 3 and the negative 6, does that affect like the a squared, b squared?
It doesn't. And let me get through this here in a second. Does everybody have this written down? And I'll show you where you're going.
No.
Okay. I'll let you guys finish writing that out. When we're looking at this right now, when I'm looking at this right now, could you guys tell me what direction this is going to go?
Yeah.
It's going to go up and down. Does everybody agree on that?
Yeah.
We agree on that because I know that a squared is 49, b squared is 25. So how do I find c squared again?
A squared minus b squared.
Same stuff, so it's 49 minus 25, otherwise known as 24. Everybody okay with that?
Oh, yeah.
All right. What's A?
7. B plus or minus.
Thank you. It's okay. B is plus or minus 5. What's the square root of 24?
2 root 6.
Very good. 2 root 6. So it's plus minus 2 root 6. What's my H and K?
3, negative 6.
Good. So we know that our center is at H and K, which is 3, negative 6. You have enough information to do everything you need to know. Here's what happens. We start with our center. There's my center. Everybody okay with that?
Yeah.
My vertex has to go up 7 from that. Do you agree?
Yes.
And it has to go down 7 from that. So if I add 7 to -6, what do I get?
1.
If I subtract 7 from -6, what do I get? Everybody okay with that?
Yeah.
So I know right off the bat that my vertices are at, well, 3 for the x-coordinate. Since I'm stretching up and down, I'm adding my a value to the y-coordinate, which was 3 and 1. There's my vertices. When I'm plotting these things that are shifted, I want to label them as soon as I figure out where they are. That way I don't forget it.
Oh,
Does that make a little bit more, a little sense there? Yesterday we plotted all 4 of all 6 of our points first, then we went back because the numbers were already centered at 0. Yes, sir.
Sorry, I wasn't here yesterday, so I don't, why didn't you put those other 2 dots?
Those are the vertices. Okay, the vertices are found from the distance, or your a value. The a value gives you the distance from your center to your vertex. Since we know that this is stretched up and down, there's going to be one on top and one down below. So here I add 7 and I subtract 7. Okay? And then to do the vertical then, I'm going to add, what is it? Add 5 and subtract 5 to what number?
3.
3, good. So I add 5 to 3, I wind up at 1, 2, 3, 4, 5. I wind up at -8, or excuse me, +8. And then I subtract it and I go -2. We okay with that?
Yeah.
So my covertex are at 8, -6, -2, -6.
And is that it?
Only thing that's left is to get the focus here. This is the weirdest one of them all. Now, I do want to ask you guys one quick question. Do you see why I asked you guys not to write ±5, 0 and stuff like that yesterday for your vertex and covertex and all that? The reason that I didn't want you to do that is because here it doesn't always work like that. I wanted you to get in the habit that you have to add and subtract in both terms. So that's why I was saying that. Now, the C value. The C value represents the distance from the center to the focus. Remember that?
Yeah.
Now, our center is located at 3 and -6. I know that I'm going to have to add and subtract to the y value of that ordered pair. Do you agree? Now, I really can't just take -6 and add 2√6 and get -4√6. Do you agree? So is this a legitimate y value? Absolutely.
Is it like you put more parentheses?
Yeah, because what doesn't change here? The x-coordinate doesn't change for that, because our foci, 2√6, square root of 24 is almost the square root of 25. Do you agree?
Yeah.
So it's about 5-ish away. So if I say if I wanted just to plot it to get the idea of where it's going to be, here's 1, 2, 3, 4, 5-ish, and here-ish. So those are my foci. So if I go to make this, remember, vertices always open to the focus. Since I'm adding vertically here to the center,
Wait, where?
Is that it?
about 5.
5 away from
Well, we're looking at the square root of 24. Do you agree?
it? Yeah.
Square root of 23 is almost, or 24 is almost the square root of 25.
So you move 5 away from the center.
Yep. 5-ish. Almost. Remember, I'm not putting it specifically, because what I'm going to do now, ladies and gentlemen, what I'm going to do now is work with my focus points. When I'm working with the focus, in this example, since it's stretched up and down, which coordinate doesn't change?
3.
The 3, the x-coordinate. So for both of my focus, both my foci, the x-coordinate is going to be at 3. One of them, well, it'd be -6, add the 2√6. The other one would be -6 minus the 2√6. And that is how you leave your answer. Yes, sir?
Wait, why do we have to find the foci? Why can't we just do the 4 points and just connect them?
Because it'll ask you where the focus is. Because all of these, all the ellipse have basically four things. They have a center, vertex, covertex, and foci. We can actually talk about the lattice rectum if you want.
Rectum.
Yes, that's what it's called. When we get to hyperbolas, we're going to talk about slant asymptotes. I'm not lying, there really is something called a lattice rectum. It's kind of funny, because it's talking about a plummet. But we don't worry about that. Yes, ma'am?
What is the -6?
The -6 is the y value at the center. So we're starting at the center and walking to our focus. Our focus just has a weird root. It's not like 6. Exactly. Because I'm just changing, because I'm adding it vertically, so I'm changing the y value. If I was going the other way, I'd add it to the x value. Okay? What do you guys got, Izzy?
I was thinking the other reasons.
All right, we were talking about how you got the -6 plus 2, 6.
Remember, all I'm doing here is that your focus is your C value. Your C value is the distance from the center to the focus. If C equals 2 root 6, to move up, I add root 6 to negative, or 2 root 6 to -6. To move down, I subtract 2 root 6 from it.
I was.
That's all it is. It just happens to look like a crummy number. That's all. Remember yesterday, we always wound up with more often than not, you wound up with weird values for foci? It's the same thing. It's the same.
Will it be like that most of the time?
Most of the time, yeah. Most of the time, you're going to have at least one of them that has some funky root in it. Okay? So, setting up and solving and graphing these things, like you've noticed from yesterday, are relatively easy. So let's talk about how you write the equations then. Let's say you're given this. Let's say you're given the foci at 5, or 3, 5, and 3, -1, and vertices at 3, 6, and 3, -2. You need to write the equation. I'll write that up here. I'll show you what we're going to do. I bet you could probably tell what step number 1 would be here. Draw it.
Drawing is
Oh, astrophysicists is physics. Talking is hard, apparently. So if I have foci at 3, 5, and 3, -1, vertices at 3, 6, and 3, -2, we need to figure out what's going on. So we plot it. Those are my foci. My vertices then are at 3 and 6, 3 and 6, and 3 and -2. Can you tell right now what direction this is going to go? It's going vertically again. Does everybody agree on that?
Yes.
Remember, same thing with parabolas from earlier, that vertices always open up to the focus. So I know that this is going to wind up looking like this, which means when I write it out, I'll have x minus h quantity squared over b squared plus y minus k quantity squared over a squared equaling 1. What don't we know?
the center.
The center. Well, what would you do to find the center?
Find the distance between the foci.
And then what?
And divide by 2.
Very good. Remember, those values of A or the values of B, bless you, the values of C, they're always equal. They're the distance from the center to a focus, the center to the focus. You're going in both directions, the same value both ways. So if I can figure out how far apart, whether I want to talk about my vertices or my foci, if I find the midpoint of them, there's my center every time. Every time. Now, I bet you could probably tell from looking what the x-coordinate of your center is going to be. 3. I know that my center, my h and k, has to be located at 3. So let's see here. 1 little 2, 1 little 2 little, 3 little spots, 4 little 5 little 6 little spots, 7 little 8. What's half of 8?
4.
Thank you for checking. So I count 4. 1 little 2 little, 3 little spots, 4.
It's like really learning your song because you keep pausing it.
I try. So where's my center?
3, 2.
3, 2. Now, ladies and gentlemen, that's all you would have to do to find the center, is walk it. You're finding the halfway point. The worst thing that could happen is maybe you might have an H and a K that works out to be a whole number and a half Z. Okay, but more often than not, they work out clean. That's good.
So how did you find like the 8 before?
How to find the 8?
Yeah, how did you figure out that you needed to go 4?
Oh, remember, the distance between here to here was 8.
Oh, okay.
And this is just halfway. Because this is always the halfway point of, the center is always located halfway between their co-vertices, the focus, and the vertices. It's always, always, always the
You
halfway
just
point.
moved 4 spots and aligned them?
Yes.
Or like half
Oh,
of?
yeah.
Okay.
What was the other thing we did when we had to find like the middle of it? Add that and divide by 2.
That was when we were doing zero scratches, symmetry.
Can you do the same thing with this? So you just add the y's?
All I did was, yeah, I added the y's together and cut it in half, and that gives me a little more. It's the same thing.
Okay.
All right. Now, I know then, if I move this back out of the way, I can go back and count now. We know that the distance from the center to the vertex was 4. So is that an A or a B?
A.
It's A. So I know that A equals 4. I also know that C is equal to 3. So what's A squared?
16.
What's C squared? How do you figure out B squared?
Oh, yeah.
Yeah, remember, C squared is A squared minus B squared. So 9 is 16 minus what?
7.
7.
Oh, yeah, I was adding.
So now you know enough information to solve the problem. You know that your H value is 3. Your B squared is how much?
7.
Your Y value was, or your K value was 2. And then lastly, over 16.
1. That's it.
That's it.
Alright.
The tricky part of when you're working with a shifted ellipse is that you got to do that one extra step of finding the center. Just like when we graphed it, you had to find the center to start graphing. Now you just got to find the center to write the equation. But you notice it's not that scary, is it?
Not that bad.
Hopefully. Hopefully.
Hopefully not.
And then, so let's think about this. When we did shifted parabolas, we wound up with having to write the equation graphing them out with their H and the K. Then after that, you wrote the equation given a directrix or a focus point. And then, what was the last thing you had to do? Complete the square. So, what do you think I'm going to have to show you now?
Complete the square.
Complete the square something. All right. Last example. The last scenario that occurs here is if you're given an ellipse in what they call a standard, in a quadratic form. You wanted to make it look like standard form. You wanted to make it look like x minus h quantity squared, blah, 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 blah. Now, when we did this with the parabola, we just got the square term on one side and moved all the other junk on the other side and completed the square and went. When we're dealing with an ellipse, you're going to complete the square twice.
Yay.
Okay? So here's what we did. And this is, it's the same process each time you see a problem like this. And if you remember we did complete the square last time around, the numbers work pretty clean. It usually happens with this as well. What I want to do is regroup the x squared terms and y squared terms together and move the constant to the other side. So I go 9x squared plus 36x plus 4y squared minus 24y equals negative 36. Everybody okay with that?
Yeah.
Now, here's where I need you guys to remember the rule, what the first rule of completing the square was. What was that?
dividing B by 2.
No.
Negative 36.
Taking out the a. You cannot complete the square until your leading term coefficient is 1.
Oh, yeah.
So in this case, you want to take out the a value for the x squared and the y squared. Here's what happens. And notice how it works rather cleanly here. It happens a lot like that. Factor out a 9, and you have x squared plus 4x plus blank. Everybody okay with that? I'm going to close that parenthesis up. I'm going to add in a factored out 4, y squared minus 6y plus blank equals negative 36. Now remember what we did with the parabolas when we factored out stuff. What did we have to put on the other side? Plus blank and plus the whatever we factored out. Yeah. So on this case here, I'm going to add in a 9 times something and a 4 times something. I'm doing that right away. I cannot tell you how many times I see students forget that. Whatever you factor out on one side, make sure you automatically take it, this value 9, and place it over here. That way it's staying balanced. Okay? Does that make sense?
Yeah.
All right. Now the completing the square portion should be easy. What's half of 4?
2.
What's 2 squared?
4.
So we have x squared, let me just write that. So it's 4 over 2. 2 squared is 4. So I'm adding 4 here and there. What's my term then for the x squared stuff? Very good. So this is 9 times the quantity, x plus 2 squared, plus, well, what's half of negative 6? Sorry.
Negative 30.
Good.
Squared.
And we're adding 9 to both sides?
Yeah.
Okay.
What in the world?
So 36 and on that.
Correct. My term for the y squared stuff becomes 4 times the quantity y minus 3. Equals
36.
36.
What?
Because 9 times 4
Oh,
is 36.
okay.
4 times 9 is 36.
Okay.
It's 36.
Like I said, a lot of these types of problems, you wind up with numbers that work rather clean. Okay? Almost, because what do I have left to do? Divide by 36. Almost there. Almost there. And then simplify. What's 9 over 36? And then 4 over 36. It's not as painful as it looked, is it? So let me tell you this, a little trick. If you start getting really crummy numbers, you're doing it wrong. Okay? I don't think I'm giving you any problems that give you super crummies. I don't think so.
On a test too?
I might give you a fraction, but it's not that bad. That bad.
Or we can just leave that.
But even when you talk about fractional ones, if you've got to take square roots of a fraction, I mean, 25 over 4, what's the square root of 25 over 4?
5 over 4.
Wrong, it's plus or minus, but that's okay. But you get the idea. All right. Now, from that spot, could you graph that?
Yes.
Okay.
Probably.
What's your a? Which way is this thing being stretched?
Up and down.
Being stretched up and down again, and the reason we know that is because what? 9 is bigger than 4. You'd rather have $9 than $4. The alligator wants to eat 9 Oreos. No? I just thought of an Oreo. I don't know why. I saw cookie dough Oreos the other day.
Yeah, I had them before.
Are they good?
Gross. They are
I
terrible.
don't like Oreos.
No, they taste gross.
I've had that. Have you, Jared, did you have the fried ones?
Yeah.
Oh, dear Lord. Thank God I don't know how to make those, because I would be 500 pounds. Deep fried Oreos?
Oh, how was it so
It's ridiculous. Yeah, I just,
See, Aaron, it's ridiculous.
it is ridiculous. It's ridiculous that you don't know these things. You should get out of school right now and go find them.
They have them at fairs.
Fried pickles are pretty good too.
I think it was a gross first off.
Oh, fried pickles.
Height,
Do those, please. These are all, this is out of that 10-6 again. That same, remember how we were picking and choosing the parabola stuff? I'm picking and choosing ellipses. Tomorrow, for those of you guys that made videos of songs or whatever, stuff like that, if you have not done so, try to email it to me today so that way if it gets spammed, I know where it is. If you can upload it, and we'll just get a link for it. Remember where it is, that kind of thing. Put it in your own email, that kind of stuff. Yes, ma'am. All right. The quadratic formula stuff. Yes, sir.
Do we get to watch the other classes?
Yeah, I'll show you guys the other ones. What we're gonna do tomorrow then, since that, hopefully that'll take a little bit of time. Tomorrow what I'm gonna do is walk you guys through shifted circles. I'm not even gonna bother centered circles because that's boring. Shifted circles you guys did last year. I'm not really too worried that you don't remember it. I'll show you. It should take about 10 minutes and I'm gonna give you about 4 or 5 of them to do. Hopefully you get it all done. All right, is that fair?
And we're watching the videos tomorrow.
What's up? Yeah.